Okay, welcome back to section 7.8, improper integral, and this will be the last video, and it's about the comparison test. From the name of the comparison test, we will need to compare two functions. The function that I have in the question and another function which should be satisfying at least kind of two things. It should be a simple function, and it should be something that we know whether the integral converges or diverges. And the best candidate will be the b-test, because in the b-test we know it converges or diverges very quickly. So I will give you an integral, something like this in this example here, which is a little bit complicated to find by yourself. Please try it at home, do it by yourself. It will be a complicated one. Still you can do it, but will be complicated since you just want to converges and diverges. So what you need to do, or what we will do next, is I will compare it with something simpler. Comparing means it might be greater than or less than something which is, as I said, should be simple, and we should know whether it's converges or diverges. So here is a question mark. We need to find something easier, and we continue. Now, after we compare them, what do we get? If my new function is bigger, my new integral will be bigger. In that case, we have this rule. If the bigger one converges, then the small one must be converges. And why this is true? If the bigger one, imagine in your head, the bigger one is 10. The small one will never be, imagine this is 10. This will be something less than 10, maybe 9, maybe 8, maybe 7, but it will not be infinity, so it will be for sure greater than 10. Of course, here we assume everything is positive, so we don't care about the negative infinity, and that's the story. So if the big one is converges, the small one is converges. Next, what happened if the small one diverges? Imagine the small one is infinity. What do you think the large one will be? Imagine this is infinity. What is bigger than infinity? Can it be 7 or 8 or 10 or million? No. Whatever greater than infinity, the only answer would be infinity. So if this one diverges, then this one diverges. End of story. Do you have any question? Anything you want to say? Now let's go and we apply it in example number 1. Now, how can I get this function? The first intuition, maybe it's correct, maybe it's not correct. I want you to take the highest power in the numerator, which is x. I want you to take the highest power in the denominator, which is x3. X over x3, it is 1 over x squared. Okay, so I'm comparing the blue function with the pink function, and I don't know, is it greater than, it is equal, it is less than? How do I do? One way, if you want to make sure correctly, substitute x equal 10, 100, 1000. Substitute them here and here. If you have a good calculator, you will see which one is bigger. Okay? And I would say, I believe this would be bigger. Maybe equal, but this is the direction. The next step, just write the integral in front of each one. It was from 0 to infinity. Sorry, this is not 0, it's just 1. Okay. Now I want to ask yourself, is this converges or diverges? It is converges by, you have to write the reason, by the b test with b equal to 2. So the right one is converges by the b test with b equal to 2. Now, if the bigger one is converges, what can we say about the small one? By the comparison test, you have to write the reason like this. By the comparison test, this integral converges. Okay, this converges. That's the first example on comparison test. Comparison test, we compare one function with another. The new function should be simple, something we can know whether it's converges or diverges, and the only way we know if we use the comparison test or the p-test. Let's do another one, quick here. So I need to compare x plus 1 over square root of x4 minus x. I wish to compare it with something easier. If I try the same way I did before, I should write an x here, and I should square root of x4, and that will be x over x squared, and that will be just 1 over x. Now you need to compare them. I don't have a calculator, and the way to compare them, please try x equal 10, 100, 1000, whatever, depending on your calculator. I think that this would be greater than or equal. And the next step, just write the integral in front of each one. Okay, and now this is diverges by the b test with b equal 1. Now if the small one, now this is the small one, you can imagine this is smaller than this. Now if the small one is diverges, then the large one diverges. And the reason is by the comparison test. Please, if you have any question, you can ask me in the lecture, you can ask your instructor. And by this, we finish section 7.8, improper integral. Thank you.